Welcome to Chapter 6 of the Commodore Plus 4 User's Manual. And today what we're going to do is learn beginning basic programming. Now, we've been programming in BASIC for some time throughout these chapter tutorials, but today we're really going to dig in deep and learn really about how to program in BASIC. We're going to be using things such as input-output statements, control statements and loops, conditional and decision-making statements. We're going to look at subroutines, and then we're even going to learn about remark statements. So all the things that you need to be productive and to begin building your own BASIC programs using Commodore BASIC 3.5. Before we get started, I do want to remind you that there is a comprehensive set of show notes or a companion blog post at stephencombs.com/plus4-7. And that's all the lead in we need. Let's go ahead and get started with beginning basic programming. Okay, before we get started, I do want to remind you about the companion page that goes with this series. You'll find the links to all the episodes. You'll also find links that I discuss in every episode. And if you scroll down the page, you'll also find a brand new feature, the companion disk image. This is a .d81 disk image that contains all of the programs I demonstrate. So you simply download that .d81 file, you fire up your Vice emulator, or you use an ST to IEC device, and you can load all of the programs that I demonstrate in this series. Let's take a sneak peek at the .d81 image file in Directory Master version 3.1.5. You'll notice the list of files, including the chapter number and a fun title that should make it easy to identify which program I am demonstrating. Okay, let's begin Chapter 6, Beginning Basic Programming. And here you see the user's manual. I also have my handy dandy set of show notes that I'll be referring to. You can find these on the companion blog post. Link will be in the video description or below. Take a look below and you'll find the link. You really want to check these out. I spent a lot of time adding to the user's manual as well as correcting mistakes. And they've just become a great resource for those of you that want to learn more about how to use your Commodore Plus 4. The first thing we want to talk about are programming modes. The two programming modes on the Commodore Plus 4 are direct or immediate and indirect or program mode. Direct mode executes statements immediately, as we saw in Chapter 5. And here's an example, 2 + 2 = 4. For indirect mode or program mode, we need to have a long program. So what I'm going to do now is I'm going to break out my trusty Pi 1541, which by the way, I put together and demonstrated in another video, link to that below and in the video description. And I'm going to load the retro combs.d81 image file that I shared at the beginning of the video. And now that that image file is loaded, we are going to load our first program. Here's a directory. This should be similar to the directory we showed in Directory Master at the beginning. And now we have our disk image ready if we need to load a longer program. For now, though, what we're going to do is we are going to type in a program in indirect mode. As I mentioned, we use indirect mode to create basic programs. We've been doing this since early in the series. You create a line of code by prefacing each program statement or line with a line number, followed by a single command or multiple commands if you separate them by a colon. You may remember that tip from a previous chapter. You store each line of program in memory by hitting the return key afterwards. Now, once you have the program created, such as the example I've shown, we type run and the code executes. If you want to stop that code from running, you hit run stop. You may have noticed in previous examples that we've been numbering program lines in a series of 10. So the first line is 10, the next one is 20, the next one's 30, so on and so forth. Basic programmers do this so that they can insert code between those lines if they need to make additions. However, Commodore BASIC 3.5 includes a renumber command. So once you get everything in there the way you want it, if you still want those to be spaced out in tens, you can renumber that particular series of code steps. And there is a full description of the renumber command in the encyclopedia at the back of the user's manual. The next topic for us to look at are input and output statements. Input and output statements allow programmers to communicate with an individual running a program or other devices connected to the Plus 4, such as a dataset, joystick, disk drive, printer. We've used I/O commands such as print And I would like to describe that now with this output statement line you see that I'm typing. Print is an example of an output statement. It outputs data that you have stipulated in your program. You'll notice that I'm using the print statement in direct mode, which means it's not a program line. It is a statement that is being executed immediately when I hit the return key. So next I'm going to use question mark, which is the shortcut for the print command. You can't bring your friend into the control room. No friends in the control room when I'm recording. And you'll notice I hit return and it immediately prints that line. Those two print statements are examples of printing string data. If you'll remember, in direct mode, we can also perform calculations. In this direct mode command, I'm going to print 58 times 15 with a comma. Remember, when we print, we add a comma. That will move the next result 9 characters over. It's kind of like a tab. Then we're going to print the number 23. Then we're going to print the result of 45 plus 1,000 minus 45 times, open parentheses, 4 minus 3, close parentheses. So we move through that, we hit enter, and we get our result. And you'll see that it prints those 3 results at every 10 characters on the screen. Okay, for our next output example program, we're going to load up a file from our 1541 disk image. This will be file 06RNN. You will understand why I call it RNN when you see the program. Let's go ahead and get that loaded. Let's list the program. And so let's go ahead and scroll up here and look at each line and see what we have. We have 10. R is equal to 10 times 2. Now you'll notice we have that colon again, so that means we can add another command within the same command line, and we will use n is equal to r minus 5. Then we're going to print some results, and then we're going to print an output that kind of describes what is happening in the program. Let's go ahead and run that. Let's go ahead and clean up the screen so we can see the program by itself. So we'll go ahead and run that again. And here's our result. You'll see r is 20 and n is 15. But r times 2 is 40 and n minus 2 is 13. Let's go ahead and pull up our directory and load another program. Let's scroll up here and we're going to type in deload same line. Then what I'm going to do is go to the end of the line and get rid of that PRG. You can do that right within the program listing. You'll notice it loads. If I screen clear, that'll get rid of that area so that I can list the program. And then it says print these 2 sentence parts will be printed one after another. And the reason that is because we have this semicolon, and it's just another example of how you can use print to ensure that the lines on 2 separate program lines are printed together. And that's a little hard to read because it doesn't appear all on a single line, but trust me, it all printed one after another. Now, let's go ahead and look at input statements. Now, we've looked at output statements. Input statements allow you to receive input or collect user and user-defined data from a program or from a user. The first example that we're going to talk about is going to request user input and then reprints that input as part of an output statement using a print command. Now we're going to go ahead and load another program from the image file. You'll note I didn't need the end quotations at the end of the deload command. I'm trying to show you some shortcuts so that you can speed along in your +4 programming and using your load and save and run and all those fun commands. So here's the command we were talking about. This is what is your name? It's going to ask you for your name, and it's going to say, I'm pleased to meet you, whatever your name was, through that variable, $. That is a string variable. Then it's going to say, how old are you? And it's going to have another variable, ag, that's a numeric variable, and then it's going to print that numeric variable and say, hey, is a bit older than I. So let's run that and see exactly what we get. So here we go. What is your name? Well, my name is Retro Combs. That's me. And how old are you? I'm ashamed to say I am, well, I'm not ashamed. I'm happy to be 55. There we go. And here's the results of the program. So you'll see that we received input from the user and then used output commands to output that input. So that is input-output statements in a nutshell. However, there is another input statement that Chapter 6 introduces, and that is the getKeyInput statement. This statement accepts a single key press and requires a string variable such as $. The command does not require you to hit enter after you type in your input. So what I'm going to do is load another program from disk. This is file name 06A through F, searching for that file. It's ready to go. Let's take a look at it. Here's our file. You'll notice at the line 1000, it says print, please choose A, B, C, D, or E, or F. It's going to say get key. It'll take that selection that you choose, and then it's going to print that selection. Let's go ahead and run through it. Now remember, I don't have to hit enter at the end of my input. I just strike a letter, S, and it prints it. Now what you'll notice is as I run this, it will type any letter that I type. There is no error handling in this. So if I choose something other than A through F, it'll still print that. That'll come a little bit later when we narrow down the selection of the correct input or not. Let's load one last input statement, and this final input statement is the read/data statements. The read statement is similar to the input command. However, a program receives information from the code rather than a user. Information is stored in code using a data statement, as you'll find. And I'm loading up a program now that will demonstrate the read data statements. Let's go ahead and list that. You'll see we scroll up here to 10. It's reading A string, B string, C string, D string, E string. So it's going to read 5 bits of string data from data statements. Now, once it reads those data, it's coming down to line 30 to grab that. So it's Groucho, Harpo, Chico, Zeppo, and Gummo. If you don't know who those folks are, you should really research them on YouTube. And then once it receives that data, it's going to use a print statement and print out that data or those string variables. Let's go ahead and run that code and see what happens. Now I ask you, is there any better example of the use of read and data statements than to pull up the names of the Marx Brothers?
Stu!
Yes, sir.
I say, Stu.
Yes, sir.
What do we got for dinner?
Anything you like, sir. You might have some tomato juice, orange juice, grape juice, pineapple juice.
Hey, turn off the juice before I get electrocuted.
Just a little word of caution. You need to remember that the read variables must equal the same number of data variables, or you're going to get an out of data error in some line. So be careful with that as you're creating your own read data statements. The next concept, control statements and loops, is where really the magic happens in basic programming. We can execute a line of code one after another, but we can also jump around within code lines using something called control statements. Using loops, we run code over and over and over until we hit the run stop key, or we specify in the code for a group of code lines to stop after a specific number of times. In previous chapters, I would demonstrate a program that continually displays a line of text until the run stop key is hit. I bet you're sick of it, right? And here it is again, the famous retro combs program. We run that, and you see that it continues to run indefinitely until I hit the run stop key right over here on the left. The command that caused that indefinite loop was the goto command in line 20. Now, let's look at a cleaner way and a better way to do that. And that better way is using something known as a do loop statement. So what I'm going to do now is, instead of using the goto command, I'm going to use do loop statement. So you'll see line 10 is the command do, line 20 is the command print going up. And I meant to put a semicolon in there, but I have a colon, which means the going up is not going to be next to each other, but you get the point. We'll go ahead and run that, and you'll see that that will run continuously again until we hit the run stop key. So here is another example of an indefinite loop using the do loop command as opposed to the goto command. Now, some of you may be saying, hey, RetroCombs, that doesn't look more efficient because that was 3 lines of code to do the same thing that you did with 2 lines of code using the goto command as opposed to the do loop command. Well, let me just show you how we can do the same thing with the do loop statements in 2 lines of code. So here you find we have 10 do. Remember, we're going to use the colon, add another line, which in this case will be the print statement that we used. And if I can type here, let's try that again. There we go, RetroCombs. And then for the next line, you can probably guess what we're going to do. Now we're going to go ahead and get the semicolon in here and do it correctly this time. And for the last line, we'll just say loop. So there's 2 lines of code to do the same thing we did with 2 lines of code, creating an infinite loop to print RetroCombs on the screen. Let's run it and see what we get. And there's our RetroCombs indefinite loop program. Let's hit run stop to stop that. And I have demonstrated how you can use do loop in 2 lines. You could actually do all of that in a single line. Can you figure out how to do that? I bet you can now. Let's continue to create finite loops using something now we call for next statements. I'm going to load up the Count Up program from my disk image. We'll list that, and let's go ahead and go through each of these lines. You'll see, first of all, we want to print count up. Then here's that for statement. We're going to say for j equals 1 to 10. So j is going to count from 1 to 10. And then we're going to print, we have j, that'll print the current value of j. We're going to next j, which will jump back up to the for statement. And it'll keep doing that jump for 10 times until we've got to the last line where we say, print, we have counted up to j. Let's run our program and view the results. And here we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, 9, 10. And then it says we have counted up to 11 because it went through the for next loop 10 times with the final j being 11. That example counted up by 1, but what if you wanted to count up in steps of a specific increment or value such as 5? Well, believe it or not, we have a command for that, and that is the step value. We can add step to our for next loop. And so let's go ahead and make some modifications so that you can see that example. So we're scrolling back up to line 20. We're going to make some modifications to line 20. We're going to say for j is equal to 10, and we're going to keep the 2, and we're going to change the final 10 to 30. And then we're going to make a addition to the line. We're going to say step through that 5 times. So now it won't be 1 through 10. It will be 10 through 30 in increments of 5. Here's our original program again. I want to run that so that we have those values on the screen. Now what I'm going to do is go back up and change line 20 again. And then what we're going to do is run the results on top of the old program. And you'll see now, instead of 1, 2, 3, 4, 5, it scrolls up to 10, 15, 20, 25, and 30 in steps of 5. So there's an example of how we can use the step command to change our finite loops in increments of 5. Okay, now we're going to have a little fun. Let's go ahead and clear our screen, and let's go ahead and new out our old program. Let's load a new program I have called 06 Liftoff. Again, this is on the .d81 image that you can download. Okay, and it's searching, it's loading. Program is there. Let's go ahead and list that program. And here's our countdown program. So this is your basic NASA countdown program. So we're going to say print countdown. We're going to go for j is equal to 10 to 1 step -1, which will reverse the count from 10 down to 1. And then it says print, we are at, what is j at that point? Is it 10, 9, 8, whatever? What is it? And then you'll see that I have added a line. This was not in the original program from the user's manual, but I added a little line to kill some time. And I'm going to use a remark statement to remind you that this is my mod for the program. We'll talk about remark statements here in just a second. Then we do next j, which jumps back up. We do print, we have liftoff. So we've listed the program again. And what I want to do first is show you what the original program did. So while I have line 35 in there, we're going to go ahead and move that to line 55, which will put it at the end of the program statements. You'll see that right there. And then I'll use the delete command to delete line 35. Now this is my own addition to the user's manual at this point. This was not included. I thought I'd sneak in that command. And then when we run it, you'll notice originally it just does that faster than you can count down. Now that's not realistic. Whenever we do a countdown, we need some drama. So our line 55 will add that drama. Let's get that back into our code and see how I have modified the program to be a little more realistic and dramatic. So I'm going to scroll back up to line 55, change that back to 35. That'll put it back in the correct order. Let's go ahead and list. And now let's run the program as it should be. We are at 10, 9, 8, 7, 6, 5, 4,
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Up to this point, our +4 has been a basic calculator, albeit a pretty smart one. However, it's time for the +4 to grow up and make its own decisions using something called conditional or decision-making statements, such as if-then statements. In other words, if this happens, then do this. We often use if-then statements to act on user, keyboard, or joystick input, as we're going to demonstrate here in just a bit. The program that I'm going to load is going to ask the user to enter the 10th letter of the alphabet using the keyboard. It'll evaluate whether the user's input is correct, and then it'll either chide or reward you if you get it right or wrong. The program will continue until the user enters the correct answer, which, by the way, is J in case you're not following along. So let's go ahead and load my program, 10th letter. Now, before I describe the program, let me tell you the program example in the book was a disaster. So I had to make several corrections. So what you're going to find in my example is a corrected version. So the first thing we do is we ask for input. That's that A string. What's the 10th letter? The next thing we do is check to see if the value is correct. If A string is J, then print, hey, correct, you got it right. Now go to line 50. In line 50, if we jump down, it would say print, you have answered correctly. So you're going to get an output that says, hey, good job. And then you'll see that colon, which means we add another command, and then we're going to end, which stops that program. Now, that is if you get it correct. If your answer is incorrect, it's automatically going to default to the next line, line 30. You don't need to reevaluate. You're either correct or you're not. So then the next line says, hey, you didn't get that right. Do you want to try that again? And so there's a condition, yes or no. Do I want to try again? If we do, then let's jump back up to line 10. If we don't, then else. Let's go down to line 60 and print, stumped you, huh? Don't want to play anymore, you coward. So that's kind of how this program operates. Now what we're going to do is we're going to go through the program and go through the different scenarios so that you can see how this program works. All right, what's the 10th letter of the alphabet? Let's try J. Yes, correct. I answered correctly. So why continue? Good question. That's the way it was in the user's manual, folks. I didn't write that line. Now run again. What's the 10th letter? It's D. No, it's not D. Do you want to try again? Yeah, let's try it again. I hit yes. Let's try it again. J, I got it right this time because I remember I learned from my mistakes. Let's run it again. I say P. Now, do you want to try again? No. I stumped you, huh? So there are the decisions and output based on those decisions or that decision making or conditional statements in our basic program. The next topic in the user's manual is something known as subroutines. We create a subroutine to execute the same code over and over in larger programs. Subroutines allow you to jump or go sub to a code's location and then return to the original code where the go sub occurred originally. Once the subroutine is complete, this may sound like a goto statement. However, with goto, you have to know specifically which line to return. The go sub return combination does the heavy lifting for you and will reduce errors if you renumber lines of code. On the screen, I have loaded a program called 061 to 10. The code prompts the user for a number between 1 and 10. If the number entered is within that range, the program will prompt for the same range again. If the number is not within that range, or n is less than 1 or n is greater than 10, the go sub statement will send the code execution to line 100 that prints a statement saying the number is out of range. Hey, give it another shot. When two numbers within range are entered, the program will finally add the values of those two numbers. So as you can see in the code, we'll go down here. 10 is is equal to 1 to 2. So we've talked about 4 next loops. So you should know what that does. We're going to type a number from 1 to 10, input that into a or a number variable. We're going to condition that if it's less than 1, then go sub to 100, print that number is out of range, continue down to 110 after that, and then continue down to 120 and say, hey, return, which means, hey, pop back up to where we left off. And then we kind of come on over and continue that line, which says, hey, go to 20, which pops up to the top. So you have to be careful and follow that logic and see how it's jumping around within the program. That's the power of go sub statements and subroutines. Again, looking at our condition code in line 50, if it's greater than 10, we again jump down to go sub 100, which is going through that out of range again, and then back up, and then to go to 20 again. Now remember, we have to get a number between 1 and 10 twice in a row before it'll execute line 60, which is to add the two numbers together. As long as we're keeping numbers typed between 1 and 10, it will execute that operation. All those numbers that are beyond 1 or 10 outside of that range will get kicked out, and it will just keep in this indefinite loop until you finally get a number between 1 and 10. So we've got a little error correction here, a little error handling happening, which is really nice and shows a good example of how you can ensure that you're getting the input you want from the user. Now all I'm doing here is moving the end command up to line 80 to make it a little bit tighter code for me as I review the code. Let's go ahead and run the code. Type a number from 1 to 10. We'll type 1, we'll type another one, 2, and you'll see that it finally adds those two values together. Let's try it again. Let's try 12. That should be outside the range. Perfect. Goes back. Type a number from 1 to 10. There's 12 again. Yep, still not working. Let's do 78. Yep, that's beyond 10, so that shouldn't go. 3 is good. And let's do 89. That's beyond the range. And finally, let's do 3, and it will add those two numbers. So you see it keeps count of how many correct values between 1 and 10 we have before it adds those two values together. The last section of Chapter 6 is Rem Statements. We use Rem Statements, as you've seen throughout today, to add comments to code. These can be your own unique lines or added at the end of lines. Rem Statements are often used to show credit or describe a line's operation. Let's take a look at a few examples. Line 10 is an example of a Rem statement that is its own line of code. In this case, I'm creating a title for the BASIC program with the name, Rem Statements. Line 20 will be another Rem statement that's going to list who coded this program, who was the author of this program. These are two lines of Rem statements that are commonly used to specify or give credit to whoever developed the code. You can also do things such as create a calculation in a program statement and then follow that calculation by a Rem statement to describe what that calculation actually does. In this particular case, a pitcher's ERA. And our last Rem statement follows an input statement, input A, comma B, to explain what the variables A and B represent. So in this case, remember, A is height and B is weight. Now remember, Rem statements help code readability, portability, and transferability. However, Rem statements use memory, so use them sparingly in long programs that are pushing memory limits. After all, we only have 60,671 bytes free on our Commodore Plus 4. And that concludes Chapter 6, Beginning Basic Programming. Now, just as a summary, this is not an exhaustive study of BASIC nor a complete tutorial. We've only covered a fraction of the commands available. I would encourage you to read the BASIC 3.5 Encyclopedia beginning on page 101 in the user's manual to really begin your journey. BASIC is a capable and fun language that can bring you hours of fun and help you solve real-world problems. Now, next time, we're going to dive into graphics. And graphics is really where we have some fun with our Commodore computer. I'll be hard at work until our next episode, Chapter 7, typing in a lot of BASIC programs that exploit and use the graphics commands found in BASIC 3.5. I'm looking forward to sharing with you this chapter. I've already had some fun preparing an outline for the chapter, playing with some of the programs. And as I mentioned, remember, all of these programs are now on the companion disk image that you can find at stephencombs.com/+4. Scroll down the page and you can download your own image. You can load those images, you can modify them, because that's where basic exploration and learning really is more fun. When you take somebody else's program and you modify it to do the things that you want it to do, similar to my countdown or liftoff program that I shared with you earlier. As I always remind you in every video, make sure you hit subscribe, you hit like, you hit notifications, you take care of all the business down below, because I think you're going to want to follow along for the video I have coming up, especially if you are a Commodore retro computing enthusiast. I have 2 items being delivered within the month. For later on in the month, actually I believe it's December, I have the VIC-20 being delivered, and we will cover that and open the box and look at that device. I also have more exciting, or equally as exciting, depending on where you are on the Commodore retro computing fence, I have a Mega 65 that will be delivered supposedly on Black Friday or the Friday after Thanksgiving in the United States. So I plan to do a live stream of that open the box, as well as first use and assembly. So if you will hit the notifications down below and subscribe, you will receive a notification if I go live or when I go live with that video. I would also encourage you to follow me on Twitter at Stephen Combs, and you can follow along and find out when I go live. You'll also find out when I post new videos. You'll find out about other things I'm doing on my blog at stephencombs.com. Not only do I do retro computing over there, I also do gadgets that I think retro computing fans will enjoy, although it could be any gadget fan for the types of devices I demonstrate, open the box, first use, all those things I do. I want to thank the 1,000 of you, actually 1,014, who are subscribers. We're slowly growing. It's about 40 folks a month. So that's some pretty good growth. I look forward to having more join. I'm really enjoying the comments you all are posting. So continue those comments. And with that, I will say until next time, Retro Combs out.